Meet Billy, and this is the map of Border Village. With these two things, we have almost everything we need to build our own Commander Keen. Well, an engine would probably help too. For this project, we need an engine that's fast, efficient, and straightforward enough for learning the basics. Of course, you can use any engine you like, always, but I'm a big fan of Godot because it's so lightweight and easy to work with. Let's get started. For this project, I'll be using two main sprite sheets. I can't provide direct links, probably, but a quick search for Commander Keen for sprite sheets should point you in the right direction. The first one is dedicated to Billy Blaze. You can see all his basic animations here, everything he can do in the game. Notice how the left and right facing sprites are drawn separately. That's pretty uncommon for sprite sheets, and it's not the last interesting detail you'll find. The second sprite sheet is our map. It's the entire top section of the very first level from the original game. So the first thing I'm going to do is create a new scene, and I'd like to start with Billy, our playable character. I'll create a character body 2D, which is node perfect for handling all our character's movement and physics. Let's rename it to player and save it in the scenes folder. As you can see, I've already set up a basic folder structure and imported out two sprites. First, let's add his sprite by just dragging and dropping it into the scene. Now I need to edit its region. Since Billy's sprites aren't arranged in a neat grid, I'm going to use a feature called Auto Slice. Godot will automatically detect each individual drawing and create a region around it. This is surprisingly similar to how the original game handles its assets, by the way. By doing this, each frame becomes its own independent image. I'll pick the first frame for his idle position. It doesn't matter which one for now, as we'll be changing it with animations later. Next, we'll add an animation player node, which, as the name suggests, will handle all our players' animations. There are many ways to do this, but for this tutorial, I find the animation player method to be very clean and easy to follow. Let's create an animation called idle. I'll set the snap options to 0.1 seconds and make sure snapping is enabled. You can zoom in a bit to see the timing marks more clearly. Now I'll create a keyframe for the sprite region, marking this specific frame in the animation. I'll make the animation 0.1 seconds long, since it's only a single frame. Now for a more interesting one, the walking animation. I'll choose the first walking frame and add a key. Then I'll move the playhead to 0.1 seconds, pick the next frame and add another key. I'll repeat this for the third and fourth frames. Finally, I'll set the total animation length to 0.4 seconds and hit play. It looks a bit strange. The animation seems to be tweening between frames. That's because by default the keyframes are interpolated. To get that classic snappy look, we just need to select all the keyframes and change their update mode to discrete. And now each frame will display instantly without any blending. I'll turn on looping and that's perfect. The walking animation is done. I'll do the same for the idle animation. It's not strictly necessary for a single frame, but it's good practice to keep things consistent. Now, for my favorite part, the animation tree. This is an incredibly powerful tool for managing animation transitions and keeping your logic clean. I'll connect it to our animation player and set the root to a new animation node state machine. Using a state machine is a very visual and intuitive way to control how the player switches from one animation to another. Let's create a few substates to keep things organized. You'll see why this is so helpful later. First, I'll make one called movement. I'll connect the start state directly to it. Inside movement, I will add another state called locomotion, which will handle basic states like walking and standing still. And finally, inside locomotion, I'll add our two animations, idle and walking. Nothing will happen just yet, since we haven't defined any transitions, but we have just built a clean, solid foundation for our animation logic. Next up, collisions. In games, collision doesn't happen with the pixels you see on the screen. It happens with invisible collision shapes. So let's add a collision shape 2D node. I'll give it a simple rectangular shape and resize it to roughly match our player sprite. It doesn't need to be perfect right now. Let's set up a quick scene to test this all out. I'll name it level and save it. For the level itself, to have a collision, it needs a physics body. I'll add a static body 2D, which represents an immovable object. Now, I'll drag our player scene into the level and run it. He's a little small. Let's add a camera 2D to the player. This purple rectangle shows what the camera sees. To get that classic retro feel, I'll adjust the zoom. Now, the camera will automatically follow the player, just like in the original game. That looks much better. Let's give our player some life using a script. I'll attach a new script, and for now, I'm just going to use the default character body 2D template provided by Godot. It already includes all the basic movement logic we need to get started. Let's run it. Well, we can't really tell if anything's happening because there's no floor. Let's add a color rect to act as a temporary ground so we can see if Billy is actually moving. I'll position it at his feet, and there we go. Now, when I press left and right, Billy actually moves. We can finally hook logic into our animation state machine. We'll create a transition from idle to walk, and another one from walk back to idle. It's simple. If the player is moving, they should be in the walk state. If they stop, they should go back to idle. Let's define the conditions. The transition to walk will trigger if velocity x is not equal to 0. The transition back to idle will trigger when velocity x is equal to 0. Of course, it's float, so the equal here is a little bit unconventional, but we can use it. Let's test it. And yes, it works perfectly. And as you notice, we didn't even have to write any custom code for it. Now, let's handle flipping the sprite. In the original Commander Keen, the artist actually drew separate sprites for facing left and right, as mentioned. We are going to take a little shortcut here and simply flip our sprite horizontally. If the velocity is positive, we are moving right, so we'll flip the sprite. Otherwise, we won't. Let's run it again, and yeah, works like a charm. Alright, that's our character basics done. Let's move on to building the level. Let me just say that I'm going to show you a very short way how to do this. In a real practical game development, that's a horrible way of doing things, but well, here we are. The level in Commander Keen is built using a tile map. In this version of Godot, we'll use a tile map layer, because tile map has been deprecated. Let's create a new tile set and feed it our map sprite. It will automatically divide the map into 16 × 16 squares, which is exactly what the original game used. And coincidentally, that's the default for Godot. I'll select all the tiles and add them to our set. Normally, you would create a tile set with a few reusable tiles. That's of course how the original game works. But since we are just recreating an existing map for fun, we can get away with this suboptimal approach. It's quick and perfect what we are doing today. I'll place my player, delete the old static body, and align the player with the starting position. It doesn't have to be exact. Since my map contains everything from the original screenshot, I'll clean it up a bit. We'll place objects like candy bars and droplets later. I've noticed the ground pattern repeats every tile, so I'll use that to fill in the gaps where I've erased things. I'll just clean up some areas, removing Billy's head from the background, getting rid of some stones, and so on. Think about this for a moment. It's a detail often shared by John Romero. In 1991, the 4-person team at id Software published 13 complete games. Working for their publisher Softdisk, they were coding in C and assembly, inventing new graphics techniques, and followed the strict rule of always shippable code. They were essentially speedrunning game development, while the rest of the industry was still learning the rules. Now, for this red ball, I'll copy part of the hill from another area and paste it over. It sort of works, but the background is a little different. We are lucky that there's at least one reusable piece that fits. Let's test the scene and... Billy falls right through the world. Well, that's because our tiles don't have any collision information yet. To fix this, we'll go to our tile set, select the physics and add a physics layer. Now I can simply paint collision shapes onto the tiles that should be solid. Let's test again, and yes, that helped. I can move left and right, and I only follow where the collision ends. I'll just fill in the rest of the floor, ignoring the hill for a moment. Now let's be a bit more creative and add collisions to the hill to make it look nicer. I'll refine the collision shape by enabling grid snapping and adjusting the vertices, removing any extras. Just cleaning it up. You can remove the extra vertex by right button click. I'll do the same for the other side of the hill, and alright, let's test it. It is moving a little too fast, so let's lower his speed to 100 and set his jump height to 350. I experimented with numbers and this seems to be close to the original game. But wait, we are falling through the terrain again. To find out why it's happening, a great way to debug this is to go into the debug menu and turn on visible collision shapes. And there's our problem. Half the hill is missing its collision. Earlier, I copied tiles from the other hill. They look almost identical, but their collision data is different. Let's copy the correct ones this time. And now, when I run it, perfect. That fixed it. I'll just fill in the hill collision completely. So now we can jump and move left and right. This looks great. We don't have a jump animation yet, but we'll get to that in next episode. The second hill still doesn't have a collision, but there's an easy fix. I just copy the first hill's geometry and paste it over. There's a small missing piece, but we can quickly patch that with the correct tile. Let's make the camera look nicer. The zoom is good, but it can move beyond the level's boundaries. We can fix that by setting the camera's limits to match the edges of our map. When I run it, the camera follows the player perfectly, but stops at the edges of the level. That's what we wanted. But there is still one small issue. We can fall off the map. It's another easy fix. I just take a tile with collision and build a small invisible wall on both sides. It looks a bit messy in the editor, but the player will never see it. I can go past the map edges, the camera stays in place and everything works smoothly. There's just one last thing to fix. Notice how everything looks a little blurry? That's because of texture filtering. For pixel art, there's one project setting you should always change. Go to project settings, search for texture, and under rendering, change the default texture filter from linear to nearest. And just like that, we have crisp, perfect pixel art. That's exactly how it's supposed to look. And that's where we'll leave it for today. Thanks so much for watching. If you enjoyed this and want to see me continue this project, be sure to hit the subscribe button. See you next time.